4, circumference and arc length. We're going to use circumference to find missing information, and we're going to learn about arc length and what that is. We've already talked about arcs. So when we talk about circumference, if you take a circular object, and it's kind of cool to do depending on how accurate you are, but if you measure the distance around, which is the circumference, and you measure the diameter of the same object, and you record the ratio and then divide it, it turns out that your ratio is approximately pi. And that's how they figured it out, is they actually did more and more, and then they proved it. But that's where the ratio comes from. So the circumference is the distance around the circle. And so it's kind of like the perimeter. And you're already familiar with this. I think we actually covered it in part of it in chapter 1. But you can either write the formula as pi times diameter or 2 pi r. And I just use whichever one is more convenient. I say I probably tend to use this one more because then I don't confuse it with area of a circle, pi r squared. But sometimes it is more convenient to use 2 pi r. Because, of course, the diameter is just 2 times the radius. So let's do a couple examples here. And again, I'm not going to work out every single one because this is pretty basic for you guys. But remember, there's a difference between approximate and exact. And many of you missed that on the last assessment. You didn't really understand what exact was. You just thought you give more decimal places, and that's not correct. So if we take a look at this first example right here, we know the circumference is 2 pi r, or pi times the diameter. So since our radius is 7, we would have our circumference is equal to 2 times pi times 7. And so circumference exactly is 14 pi centimeters. That's exactly, because there's no rounding. So that is our exact answer. You leave pi in your answer for exact. If you want the approximate answer for the circumference, then you're going to actually take and multiply 14 and pi together, and now you are actually rounding this answer, so it is less exact. It's rounded. So that's the difference between exact and approximate. So I'm going to let you try the second example here by yourself and see if you can get both the exact and the approximate answer correct, and then check back to the notes to see if you did. Here's some problems where we're going to be working backwards. So this time it gives us the circumference, and they want us to find the radius. So again, circumference equals 2 pi r. So fill in your circumference of 48. That's equal to 2 times pi times r. So to solve this, you're going to divide by 2 pi. And when you divide this on your calculator, okay, you have to make sure that you put the 2 pi in parentheses. Now, some calculators might calculate it correctly without doing that, but a lot of times you are going to need to do that. So now, when we take 64 and we divide it by 2 pi, that is actually going to give us, for an exact answer, we could actually write, oh, I have the wrong number in here. Silly me. That actually should be 48. I don't know where I got the 64. But anyway, so the exact answer to this would actually be 24 pi. That's what my radius is, 24 pi inches. Or again, if you would prefer to do the approximate answer, if it doesn't give you or tell you specifically, you could do either. So those would be your answer. The exact radius of a circle with, now they do specify that they want you to find the exact. So again, pay attention. They now want the exact radius of the circle when you have a circumference of 36. So again, I'll just go through that one with you. And you have 36 is the circumference, and that's equal to 2 pi r. So we are going to divide by 2 pi. So our exact radius is 18 divided by pi. Actually, this is actually, when I reduce this fraction, the pi should go on the bottom. that's better. Okay, so those are pretty simple problems. So let's move on to reminding ourselves what arcs are. So remember, arc is really just part of the circumference. So arc is a part of the circle's circumference. Okay, so when we did it before, we also looked at this arc could be thought of as part of the number of degrees in a whole circle. So there's two ways to look at this arc. Okay, so we did say, I'm going to make this a little bit neater here. We did say it's part of the circle's circumference, and that's how we're going to deal with it today. Or it's part of the 360 degrees of the circle. So before we talked about that arc being the same in degrees as the central angle. And remember, minor arcs are less than 30 degrees and major arcs are more than 30 degrees, and how you name them is different. So the minor arcs are less than 180 degrees. So this minor arc would be arc AB. Major arcs are greater than 180 degrees. So this arc right here would be written with 3 letters, and if we don't have one on there, we would have to actually add one. So this could be arc BDA. Okay, so that's just a little review. Well, again, in the past we talked about the arc in the number of degrees. Today we're going to talk about it more as part of the circle's circumference. And so we call that an arc length versus an arc measure. So that's the difference. So arc length right here is measured in units rather than degrees. Because remember, it's part of the circumference. Okay? So what's interesting is that this number of degrees right here, okay, this number of degrees right here compared to 360 is going to be the same proportion as this arc length is compared to the whole circumference. So you can actually set up a ratio that the arc length compared to the circumference will be in the same ratio as the degree measure compared to the whole circle 360. And we can use that to solve. Now, if I just show you a quick little example of why or how, try to convince you here. Let's say that we have a 90-degree angle in here. Well, if this is 90 degrees, then that degree measure is 1/4 of the whole circle. So then to me, it makes sense that this arc measure right here would be 1/4 of the whole circumference. So arc length is 1/4 the whole circle or whole circumference. Because 90 is 1/4 of 360 degrees. So that's kind of the math behind it. That's kind of the ideas behind it. Now, I really prefer that you write this ratio every time. Now, we know we could fill in circumference because circumference is 2 pi r. Okay? Well, when you're looking if you look in your textbook, and if we look at the next slide, they're going to have the arc length. They're going to have this solved for the arc length. So they're going to solve this for the arc length. And how would you do that? Well, you could solve it by multiplying by 2 pi r on each side, which is the circumference. And if you do that, then what you have is you have this in terms of the arc length. But I prefer you write it as the ratio, because when we get to area of sectors, then you won't have to like memorize something new. You'll just be writing the same type of ratio. But that's up to you, whatever seems to make the most sense. But here's our arc length corollary. First of all, it talks about arc length. An arc length is a portion of the circumference of the circle. You can use the measure of the arc in degrees to find its linear measure, or its length in linear units. So, in a circle, the ratio of the length of a given arc right here is equal to the ratio, in a circle, the ratio of the length of the given arc to the circumference is equal to the ratio of the measure of the arc to 360. So again, this is what I would have you write down each time. So remember, that's the degree measure of the arc compared to 360, and the degree measure of the arc is the same as the central angle in here. That's your central angle degrees. So actually, if you can understand that those ratios, the 1/4, the 90 degrees is 1/4 of 360, so that arc AB will be 1/4 of the whole circumference. If you can understand that idea, then the rest of this should go quite well. So let's try some. It says find the length of arc AB. So I'm going to find that. Well, this is the example I already gave. This is 90 degrees. So the arc length AB compared to the whole circumference, which is 2 times pi times 7, that's going to be in the same ratio as the 90 degree angle compared to 360. Now, if you want to put 1/4 in there and reduce it, it just makes your math a little bit easier. But because you're using your calculator, it's not that big of a deal. So I'll go ahead and simplify that ratio. Equals 1/4. So now I'm going to cross multiply, and what I get here, or actually to solve this, I don't even have to cross multiply. If I notice that I can just multiply by 14 pi. So then arc AB would be equal to 11 inches. Approximately. Because, yeah, okay. So, I'm going to have you try this next example right here. You try this one on your own and then check back to the notes. I'm going to move on. So let's do a whole bunch of different things here, and let's see what we can understand from combining lots of information. So, in circle D, so that tells you that that's the center of the circle, angle ADC, so ADC right here, is congruent to angle BDC right here. And then it tells you, it asks you to find the given information. Well, I haven't even looked at what they want me to find, but what I do notice is that I have this angle measure right here is 40 degrees, so I know this arc is going to measure 40 degrees. And if that measures 40 degrees and the whole thing is 360, then if I take 360 and I subtract 40 degrees, that gives me 320. So if each one of these arcs are the same, or these degree measures, then that means if I divide that by 2, then this has to be 160 degrees, and this has to be 160 degrees. So the measure of the arc is the same as the central angle. So I just got all those pieces of information. So now let's find what they're asking us to do. So in the first example, they're asking us to find arc A, C, B. Well, actually, we could have just taken 360 divided minus that 40 degree arc, and we already did that and got 320 degrees. So now we're going to find the length of the arc. Notice this is different. This is the measure of the arc, and that is in degrees. Now we're going to find the length of the arc. So we're going to find it in terms of length. We're still looking at that same arc, but we're just looking at it in length. Okay, so remember, the length of arc ACB, okay, compared to the whole circumference, which is 2 times pi times my radius of 4, is going to be in the same ratio or proportion as the degree measure, which we found was 320 compared to 360. So again, I could reduce this fraction. I can take off this, and I could also reduce that to 8/9 just to make my math easier. You don't have to. But so now we get ACD divided by 2 pi 4. So now all I have to do to solve this for ACD is multiply each side by 8 pi. And so what that gives me is that arc ACD is approximately equal to 22.34. So 22.34 inches. So there we go. All right, so now they want us to find the measure of arc ABC. So the measure of arc ABC is going to be the 160 plus the 40, which is equal to 200 degrees. How about the measure of arc CB? Well, we've already marked that as 160 degrees from our previous work. So now they want us to find the length of arc CB. So again, CB compared to the whole circumference, which is 4 times 2 times pi or 8 pi, is going to be the same ratio as the degree measure compared to 360. Again, we can reduce the fraction, not necessary, but we can at least take the zeros off, and then we can see that that fraction would just reduce to 4/9. Multiply each side by 8 pi, so that cancels out. And so our length of our arc CB is equal to approximately 11.17 inches. And now we want to find the length of arc BAC. So we already used green, let's go with blue. So B to A to C, and that is the length of it, not the degree measure. Notice the length. So then what I'm going to do is take the length of BAC compared to the whole circumference. So again, 8 pi. It's being the same ratio as the degree measure, which in this case is the 40 plus the 160, or 200, compared to 360. Again, I can reduce this fraction. So arc BAC, its length, divided by 8 pi is equal to, let's see, I can divide by 2, that would give me 10, divide by 2, that would give me 18, or I could divide by 4, that would give me 5/9. So now I'm going to multiply each side by that 8 pi again. And that gives me that arc BAC is equal to 40 pi divided by 9, which gives me 13.96 inches. Of course, one other thing I could have done is I could have found like the whole circumference and subtracted some of the pieces of the arc I already had, which would be another perfectly fine way to do it. Okay, so now we're going to try working backwards. What if I give you what the length of the arc is and you need to find the radius? Well, I'm given this arc length right here is 18 pi. Notice that the arc length 18 pi compared to the whole circumference, which is 2 pi r, is going to be the same ratio as the degree measure compared to 360, or 1/4 is equal to. Now notice I could actually, I could multiply each side by 2 pi r, but I could also reduce this fraction. So I could reduce this, take away the pi's, because the pi's cancel out, and 18 divided by 2 is 9, so I get 9 divided by r. So now maybe the best strategy is simply to cross multiply, and if I do that, I would get, 36. Wow. Say one thing, write another. 36 is equal to r. So my radius is 36 inches. All right, let's find the perimeter of the region. Okay, I'll do one of these with you, and then I'll have you try the next one. So the perimeter of this region are these two pieces, okay? And then it's also this piece right here and this piece right here. That will be the perimeter of the whole entire region. Well, this piece we know is 15 plus the other one, 15, which is going to give us 30 for those. Then we have to add that half of the circle plus that half of the circle. But notice then that's really just adding one whole circle. So the perimeter of the circle is pi times diameter, or 9 pi. So now we get 30 plus 9 pi units. If we wanted to use the exact answer, that's what we would have. But most of the time we're just going to calculate that out. So our perimeter then is 58.27 units. And then again, you try the next one, see if you can figure it out. A hint here is, remember, you have a radius, but you also have a radius that goes all the way across. So sometimes people aren't connecting these together. So